Hey everyone, today we're going to learn about logarithmic functions, and I know that from previous classes this has probably kind of been almost magic or tricky, so yeah, I hope to clear this up. We're going to do a few lessons on this. The first one is just going to kind of introduce you to it and give you some ideas for why we might need logarithmic functions, and then we'll go into it. And I really care that you guys understand why these things work, okay? So let's get started first of all with some motivation for logarithmic functions. Okay, why do we need them? First of all, I got a question, and that's what is the inverse of an exponential function? So I'm going to go ahead and sketch 2 to the x. I plot points to help me out, as you guys did last time. We plot these points, and we connect the dots, of course. And if you remember, inverses graphically, they're just reflections over the y equals x axis. So I can picture what this is going to look like. Now I could take each point and switch the x and y, so I'm going to plot those points, okay? Purple dotted line is y equals x, and yeah, their green right there is the inverse. Now the question is, what in the world is that function, okay, or what is that equation, all right? So that's one idea. Another idea I want you guys to think about is, let's go back to some math you guys have done at least starting back in elementary school. If you have 2 plus x equals 5, the question in English is 2 plus what equals 5? Well, the math answer would be 5 minus 2 equals x, and what you would do is use subtraction to find that out. Especially as the numbers get more complicated, and so you move on to multiplication here. If you have 3 times what equals 39, well, the way you do that in math, you divide, right? You say 39 divided by 3 equals x. And we use division, all right? What if we had x cubed equals 27? You're asking what cubed equals 27? Well, to undo that, or to figure out what x is, you would do a cube root, right? So the cube root of 27 equals x. And so those are roots. It could be cube, could be square, whatever, okay? Yeah. And then, so we just now got to exponential functions. 2 to the x equals 512. So the question is, 2 to the what equals 512? What math do we use to figure that out? And I've heard some guesses, but none that I agree with yet from our class. And so here is what, well, yeah, what do we use? The answer to actually both of these, both the what is that equation up there up top, and the math answer, the procedure we use to figure out what x equals in that situation, is logarithms. Okay? So, yeah, let's talk about logarithms. So let's say I have 2 to the x equals 512. That's called the exponential form because you have the x and the exponent, right? The logarithmic form of that is we say log base 2 of 512. That's how you read that, okay? So make sure you say the base and the of. So log base 2 of 512 equals x, okay? I hear a lot of people saying log 2 512. Well, that doesn't really, that could mean a lot of different things, right? So make sure you're being precise in your language. Or, for example, if you have, you see that it helps to be precise because the base on the left in the logarithmic form is the same base as on the right in the exponential form. Remember, we call that the base. So yeah, that's another reason to be precise. Another example would be if you had log base 7 of 49. That's how you say that, equals x. And changing that into exponential form is 7 to the x equals 49. I have a little trick I'll show you guys in class because you kind of have to see it in person. But yeah, that's switching between logarithmic and exponential forms. And some of the questions I'm going to give you, for example, some of the questions that are in the textbook that you'll practice in class, are just switching between these two forms. All right. So, and just a kind of a side note, if you don't see a base written, if it's like just log of 35, that actually means base 10. Okay. So remember that mathematicians are lazy, and we try to take as many shortcuts as possible. So if you don't see something there, it's safe to assume it just means there's a 10 there. Okay, that's one of the most common bases, and so they don't feel like they need to write it all the time. So generic forms, yeah, those things in the green box are equal. Okay, So the generic forms down here, we have log base b of y equals x. That means the same thing as the equation b to the x equals y. All right, and you should be able to switch between those two, and I'll show you guys again in class a trick on how to do that. All right, so let's do a few practice problems here. If you see log base 2 of 8, that literally means 2 to the what power equals 8. All right, so 2 to the what equals 8. And as long as you know your powers, that's not a hard question to answer, right? It's 2 to the third equals 8, right? So a lot of times if you can just rewrite it or say it in English what you're trying to find, you can figure out what it means. And we'll play a game to build this intuition up on Monday, okay? Alright, so let's do the next one. I'm going to do one more with you. Log base 3 of 1/9. That's, I'm sorry, those are kind of close together, but yeah, that's what that is. It's log base 3 of the fraction 1/9. That literally means 3 to what power equals 1/9. Okay? Here's a little bit tricky because you have to know that you can get fractional powers, and if you remember how to do that, or sorry, get fractions out of having a power, the way you do that is you need to make it negative. So 3 squared equals 9, so x equals 2, but to make it 1/9, you need to make it negative 2. Okay, and that's something you just either need to remember, or if you want to understand why, we can go over that again. That'd be a great thing to talk about why. Alright, so I want you to try these next handful. Try them before coming to class. That way you're ready to share with your classmates what you got, and you guys can we'll probably be working on them and other problems like them in class. So the sooner you do it, the better. Let's move on to the very last part, is graphing logarithmic functions. So I just want to really quick show you how you slide or translate and transform functions. You notice I start off by plotting the points. It always helps me, okay, and you connect the dots. So we already did that earlier in the lesson. Log base 2 of x. Oop, I just realized that is not log base 2 of x. That is, this is 2 to the x. Let me write that down, 2 to the x, okay. Log base 2 of x would look like this, where you plot these points down here. So do I do that? Nope, I do not. Let's see here. Gotta plot these points. And once you connect those, there we go. This one, this is log base 2 of x. Okay, remember it's the inverse of the power, or the exponential function, sorry. And so I just want to show you guys what that looks like when you have when you're doing these things. So you notice on the equation on the right here, where that 3 on the inside means move 3 to the right because it's on the input. Do you see those parentheses there? I really like always writing parentheses when I write a logarithm. It just helps me see what's the input. Okay, and I'd highly recommend you doing the same. Then that plus 2 on the outside there, that's going to be the output, right? So that means move 2 up. All right. So what I'd like for you to do is I want you to graph this before coming to class. And if you want to graph points, it's the same equation as the green graph on the left there. If you want to move individual points, that's fine. But let's graph those before coming to class so you can compare with your classmates. All right? And that's it. Thank you for watching.